Hello? Okay, so, alright, so we're taking a look at this one. This is the free response from the 2015 AP exam. This is the...
You're recording this?
Yeah, I'm allowed to.
That's good.
I can't, but no, because the other ones, we can't do the multiple choice.
Oh, okay.
So the free response, the free response are a one-time use type thing, but the multiple choice are stuff that they actually do. Some of them are reused again, the same type of questions.
But they're all reused.
Yeah, there's a good chunk that are, so that's why you can't do the multiple choice. You can actually look up videos the day after the AP exam, and actually, because they release them the next day, they go over those. Huh?
That does at home.
Yeah. All right.
Maybe it's time travel.
They could do it like the day before.
Go the day after.
Day after. So the day after they release the questions, and then someone will go on some math nerd will go on there and actually do it for them and show.
So I should go into the future and then go back to the.
Okay.
Okay.
All right. And
Don't touch me.
okay. So
Anyway.
So at time t0, tank contains 100 liters of water. That's important. Okay. That's important. 100 liters of water. That's important. Piecewise linear graph above shows the rate, okay, R of t, liters per minute, which the water is being pumped into the tank during a 55-minute period. So that's a rate, isn't it? So I'm already starting at a rate, which would be the velocity, right? Okay, so find R prime of 45 using approximate units. So if I'm looking at it, isn't it supposed to be somewhere right here, right? Okay, so I could figure that one out. And so let's take a look. Do I have 2 points? I have a point over here, and I have a point over here on both sides of it, don't I?
Yes.
Okay, so I have a point on there. So I'm just going to do, so my R prime, or basically A of 45, would be 0 minus 30 over 55 minus 35, which gives me negative 3 over 2, right? Negative 3 over 2, and this is the calculator part too, so you can try and make sure you actually have that. Okay, so now using appropriate units. Now, what are the units of this?
Liters per minute.
Okay, this is acceleration though, isn't it? Because I already have the rate. The rate is always the velocity, isn't it? Okay, this is liters per minute. Okay, so if I want, so this graph is liters per minute, so that's a rate, and so that's velocity. So if I take the derivative of the velocity or find the slope of the velocity, that's the acceleration, isn't it? So it's the rate of the rate. So because of that, we're going to actually go, and this is going to be, yeah, liters per minute squared. Okay, because it's an acceleration. So this is liters per minute, because it's asking for the rate of the rate. If I get the slope of the rate, that's the rate of the rate. So it's taking the derivative of the derivative. So this is not a position function. We're starting with like the velocity of it. Does that make sense or no? Speak now. No? Maybe.
So it's just the second derivative, basically?
Yeah, it's basically saying we have the second derivative because this is liters per minute, which is a rate. That's already a rate. Okay? It's so when I take the derivative of that, or the slope of that at a point. That's what I'm getting. All right, so this one is worth
That's it?
yeah.
That is not it.
Explain The meaning of your answer and the context of this problem.
She's pissed.
You're like, no.
Okay, so. Okay, and, oh, you're right, explain. Okay, so it says, now, because of this, it's a negative slope, isn't it?
Mhm.
So that means that it is decreasing. Decreasing at
And
3/2.
Negative 3 over 2 or no?
Nope, just 3/2 because decreasing is already negative,
Oh,
right?
Yeah.
It's going down.
Yeah.
So decreasing at 3/2 and liter minute squared, and when t equals 45.
So like this is like half English, half math.
Yeah, that's 2 points. So it's 1 point for all of this, and 1 point for the decreasing explanation.
Wow. This is not hard.
How many liters of water have been pumped to the tank from 0 to 55 minutes? Show the work that leads to your answer. So, what am I trying to find?
The amount of water.
Okay, so now, given that, what am I trying to get there? Am I trying to get the total?
Low distance.
I'm trying to get the total amount, right?
Yeah.
So this is basically, I want to find out every single piece, right? So is this going to be like an area under the curve?
Yes.
Area under the curve in liters, isn't it? So that's because liters is a unit that actually already deals with volume. It's a volume unit. So we're actually finding the area under this, right? So if I'm gonna get, it's gonna be from 0 to 55, right? And that's basically R of T dt. Now, since we have that graph, this is going to be pretty easy. Change questions, I'll do blue. All right. So what I'm going to do is I just want to find the area of this. So that's, okay. So let's call it 1, 2, and 3. Find the area of each. So I have a trapezoid, a rectangle, and a triangle. So let's say A1 is equal to, what's the base of that triangle?
20?
It's going to be 20. So from 35 to 55 is 20. Let me erase. So it's 1/2 because it's triangle. 20, and what's the height? What's the height of the triangle?
30.
30. A2. So that's a rectangle, isn't it?
Yeah.
Okay, what's the base?
15.
15. What's the height?
30.
Equals 450. A3. It's a trapezoid.
1/2.
1/2. And the height in this case is going to be from here to here, right?
Yeah. It's base 1.
So it's going to be 1/2. My height is 20, right?
Mm-hmm.
And then base 1 plus base 2.
Yeah.
Base 1 and base 2 are these going up here and up here.
30 plus 10.
30 plus 10. So this one's going to give me,
Wait. Go ahead.
wait, what?
For the second one, where'd you get 15?
15? What's this from right here? from 20 to 35.
Oh, okay.
Okay, so that's the thickness of that rectangle there. Okay, so that's gonna give me 400. So my area, so for this one is gonna be how many liters?
Wait, Asho?
Yes.
How'd you get 300?
What's half times 20? Times 30?
Oh, okay.
Are we okay? Alright. So together we come up with something.
Oh, all of them together?
1150?
Yeah, 1150.
Yes.
Where's 10 plus what?
30%.
Okay, what's half of 20? Times 30? There we go.
No, the third one, the 10 plus.
The third one?
Yeah.
Oh, because it's a trapezoid. And in a trapezoid, it's going to be, this is your height right here. This is your B1. This is your B2 right here. So it's going to be area is 1/2 H B1 plus B2. If you wanted to try and break it up smaller, you could have. If you didn't like the trapezoid and said, hey, let's do 4 pieces. And just said, hey, that's another piece right there, and a triangle, and another rectangle.
Okay.
That would have worked also. As long as you're showing what, labeling, okay, because you have to show the work that leads to your answer. You notice I labeled everything A, 1, 2, and 3. So I'm showing and labeling my work as I do that, because that's working off the graph.
Yeah.
So label what it is, and then you could use it. That's key. If you want all your points, that's key right there. All right, so we get 1150 what?
Meters.
All right, so this is another 2-part question. So you get 1 point for the 1150 liters, and you get another point for A1, 2, and 3. So if you have all that set up, you have your integral. If you have your integral and this set up, then you get point. 1 more point. So it's 2 points total on that one. All right, this next one says, at time t equals 10 minutes, water begins draining from the tank at a rate modeled by the function d, where d of t is equal to 10e to the sine t over 10 liters per minute. Water continues to drain at this rate until t equals 55. How many liters of water are in the tank at t equals 55? Now, we have water going in, we have water going out. Water going in is R. Water going out is D. Okay? Water going out is D. So it would be to try and find the total amount that is going to be in there, right? So in the previous problem, didn't I already find how much went in? Say yes.
Yeah.
Yeah.
We found out how much went in the previous problem. Okay? So that means that I need the answer from this one right here. So I'm going to have 1150, right? Okay? But there's one thing that I said is important. How much did we start with?
100.
100.
100. We started with 100 liters. So that's super important here. That's super important because that's part of this. Because on the other problem, we're starting with the 100, but on this problem, it's asking how many liters have been pumped into. So we only are getting what was actually added in. I started at 100, I added in 1150, okay? And so because of that, I have to have in my total amount, which is looking for, plus 100. So that's going to be our amount going in, right? That's all the amount going in. I started with 100 and I added 1150, right? Now from this point right here, what do I need to do? Anyone, take a stab at it.
Wouldn't you just use the function that it has up there and put in 55 for t?
Where we need
We
to.
just subtract the integral?
Yeah, I'm gonna subtract the amount. So yes, I'm using this, right? So all this right here was R going in, right? And so D is going out. So I want to know how much is left. So I already did the integral for this, and I started with this. So now I have to subtract my integral from,
0 to 55.
nope,
Oh, 10 to
10 to
55.
55.
10 to 55. Very good. So 10 to 55, because at time t, it starts this one right here. And then I'm going to do my 10e to the sine t over 10. And that's going to be dt, right? Okay, how many liters of water are in the tank? So, since this is a question 1, we're allowed to use a calculator, right? So this is the point where you should bust out that calculator and be like, hey, I don't want to do this by hand.
Jesus Christ. It's like
You guys
throwing
got calculators?
foam.
No, no.
We said
No.
we're okay.
Here.
I'm not gonna I'm not gonna try it. It's definitely out. Oh, I'm scared. That like gave me a heart attack.
Come on.
Oh,
Just 775.726.
7 what?
775.726.
Are you in degrees or radian?
Hang on a second.
oh my
Should be in
god.
degrees or radians.
I have 450.
Calculus always works with
Radian.
radian.
So it's.
I have 450.275.
Nope.
No?
Oh no, wait. The whole thing altogether. Okay, hold on.
325.451.
Are you
Wait, no.
Do the whole function, even the part in front.
799.7. Yeah.
So,
I'm not. I don't think I like your.
I got 799.725.
Okay, yeah. And what's that going to be? What are my units?
Liters.
Liters. It's not asking for a rate, it's just liters. How much water? How many liters of water in the tank? Okay. Use the function R&D to determine whether the amount of water in the tank is increasing or decreasing at t equals 45. Okay, so let's try a couple things. So increasing and decreasing. So isn't this all based on my graph, right? Say yes.
Yes.
And the graph was in what units? It's the rate, isn't it?
Yeah.
Okay, and so it's the same thing for D, isn't it? That was a rate, wasn't it?
Mhm.
Okay, so since those are both rates, I want to know if it's increasing or decreasing. So let's go with R of 45 and D of 45 because I'm looking to see which rate. Because R, remember, R was going in and D was going out. So let's evaluate for both of those. Not R prime, just R.
function.
The graph. You look at the graph and you find it. So you actually have to look at the graph.
Wait, do we have a graph?
Yeah, yes, you have to open the book.
Where though?
Oh, okay.
It's number 1.
Yeah, because
The free response is at the back.
Oh, that's why. That's why I was all confused. I was looking at it earlier, but
Because it said multiple choice in front, so I was confused.
that's why I have it.
Yeah, because we're gonna do. You're gonna have time to go over multiple choice. It's just I can't record those, and I would rather spend the days going over free responses. What do we get for R? Should be easy. Pick it on the graph.
Decreasing.
Okay, I'm gonna pick it on the graph. So it's where 45 is, right?
I can't tell.
Okay, 45 is here. Okay, and so watch this. I'm gonna show you guys. Okay, 45 is right there, right?
Yes.
Okay, watch this. So how far is it from here to here?
4.
Say 20.
20.
20, right? That's 20. So halfway is going to be
10.
10, right? So 35 plus 10 is
45.
45, right? Okay, so halfway from here to here, right?
35.
So isn't it going to be half of the other one too?
Yeah, maybe. Oh yeah, it goes 40.
Yeah. It is going to be proportional like that. So the slope is constant right there. So it's going to be from 0 to 30 because this is divided by 2, right?
Maybe 0 to 15.
Okay, so this is 15, isn't it?
No.
That's going to be 15, right?
Yeah.
Okay, but don't I, from the first question, don't I also know the slope here? And so for every one it goes over, it goes down 3 over 2. Yes?
You're back.
Yeah, I heard that.
It's good.
It was on the.
Oh, it's okay.
We didn't know who was in it.
Are we zoning out here?
Yeah, sorry.
She got lost.
On this one right here, I found the slope, right?
Yeah.
For every one it goes over, it goes down 3 over 2.
How did you get 15 there?
That's what I'm doing right now. On this one right here, the slope is going down 3 over 2, isn't it?
Oh,
Yeah.
And so if I'm going down 3 over 2, how many times am I going over? Isn't it going to be 10? Because it's going to be from 35 to 45, right? Times 3 over 2, which is 15. So I can get that from here also. I can look at it and say, all right, if it's half of this, then it's also half of this. So that's 15 is to there. Or I know that the slope is here and figure out how many, because for every 1 unit it goes over, it goes down 3 over 2. Does that make sense or no? So R is 15. What would I do to figure out D of 45?
What is it? Increasing.
Hmm?
Don't you just plug it in?
Yeah, just plug that one in.
It comes out to be 10 something, I think.
What is it?
10 something.
Give me some things.
Give me a second. $10.888.
Okay. So is the water going to be increasing or decreasing? Is it R going in? Is D going out?
So it's increasing.
Yes?
Yes.
Because
R is.
R goes in. Let me change. This is in and this is out. So if it's going in faster than it goes out, it's going to be increasing. And my explanation, pretty much the same thing. So water going in and is greater than water going out. It's not too bad, it's just there's a lot of parts and little things that you have to really pay attention to. Alright, so I'm going to stop the video here. I'm done with this one. Now, we're going to use the rest of the time. I want you guys. So our next problem is going to be number 3. We're going to do number 3 next. And that's